Okay, so this is week 6 of Essential of Data Science with R Software Part 2, and we are learning here the sampling theory and linear regression analysis. I'm Kamna Mishra from a School of Mathematical and Statistical Sciences, IIT Mandi, and this course is taken by instructor Professor Salam, who is from Department of Mathematics and Statistics, IIT Kanpur. So these are some useful links. Okay, so move to the main points. Uh, so in the last class, we have ended with what is the estimation of population proportion and percentage, and so we will start from there only. And the next we will see what is the estimation of population total in terms of proportion. Like till now we have seen like for average. So right now we will see for population total. Then we will see the confidence interval of that p probability. uh, After that we will go through the examples of our software. Then we will see that till now we are doing just like firstly we have done with the simple random sampling. Next we have taken in the time of population proportion, we have taken two cases that one is agreeing, another is not. So basically the population is divided into two part, and in those two part we were taking the samples. The next thing is stratified sampling. We will see that there can be several parts according to the conditions required. After that, we will have the estimation of population mean based on stratified sampling, and similar for the variance also. Okay, so these are some questions we will do later. So, firstly, we will start with estimation of proportion and percentage. So, in the last class, we have seen. So here we have seen what is sampling of proportion in percentage. That if we have population n, then we divide basically into two parts. Like if we have any requirement that whether it is in class A or class A not, so we can see in a lot of ways. So it can be a person agreeing onto something, or let's say a disease. So for disease also we can say that we can divide it. So like in the time of COVID pandemic, we have decided also that in class A star. So if person has been through like this virus, if that person had this, so we can divide it into class A or A star. So basically when there are only two possibilities, there is something when there are only two possibilities. If there are more than two possibility, then we need to divide in some other way. But if there are only two possibility, then we do not need to calculate. We have seen that we do not need to calculate for both. What we can do is that we can do each and every work just for one, and the other can be done by 1 minus p. So other probability can be found on the basis of the first one. So if the population is 40 and let's say 20 is behaving like this, then other 20 we already know because there are only two cases. So last time we have seen that in the time of population A and A star, if we have classes, we take the sample from A and A star, and that one will be the P and Q. The important thing also we need to take care of here is that we need to take approx same proportion in the classes. Like let's say in the real population there is 60% of A and 40% of A star. Right now we don't know, but then we need to do the sampling in terms that it will be around similar, it will not be so different. That so that when we will understand something from a sample, it will not give the wrong conclusions. So that time we have seen also what is y total, what is y bar, small y bar. So here we have seen a small y bar, this capital S square, this is pq, and then small s square for the sample, it is n upon n minus 1 pq. So now what we have seen is that in the proportion it is like similar to the mean only, so we can find our results similar to the mean. Okay, so now if we will move to the mean part, so here we have seen this. This is population mean. So y bar, this one was 1 upon n summation yi. So if I will do for proportion, so for proportion, what we do is that uh, we say that if it is belonging to class A, we give it 1, and if not, we give it 0. So uh, if we will take the reference from here, and if it is, let's say, just 1, so it will be 1 plus 1 plus 1, and then plus 0 for if it is not belonging to here, and then n. So that total, that will be p, because we have taken that for p it is total, so it is p by n. No, sorry, that will be m, so this one will be p. So here also we are seeing that y bar is p, and there it was uh, the average one. So small y bar is p, and here also the small y bar is unbiased estimator of y bar. Now for the variance, uh, here, so for the variance, what we have seen is that this is n minus n upon n, capital N times small n s square, and for yr it was n minus 1 upon n, and if n is like large enough, then it will be just s square upon n. So in the time of proportion, what will happen, that s square, which is the variance, that will be only be changed with pq, because here we have seen that it is equal to, almost equal to pq. So similar, we will take all the like basics from the that mean only us. Okay, so so if I will write variance with respect to this uh, p, then it will be nothing but n minus n upon n minus 1, and in place of just s square, it will be pq upon n. And similarly for this, it will be pq upon n only, because it was just s square upon n. So it will be for uh, without replacement, this one will be for with replacement. Now if we want to see the estimate of variance, so these are basically the variance of this p. If we want to see the estimate of p under these conditions, so estimate of p, these can be given by the variance this. So we do the estimate by this hat, that one will be n minus n upon n, uh, n minus 1 pq, and the variance of replacement, that one will be pq upon n minus 1. Now the proof of it is already given, uh, but it is just two lines, so we can just see that. So for the population mean, we have already seen that if estimation of y bar, so estimation of y bar is basically what, estimation of p. So estimation of p is y bar, which is P, that we have seen already here. That estimation of this small y bar, this y bar is m upon n. So if we do summation that many numbers of time, it will be capital N, sorry, capital P. uh, for the variance part, we can see that if we want to find the variance of this P, so this P is what? This P, if the sample, uh, sorry, let me write it here. So this, the sample we have here. huh. So this P is basically a small y bar because this is the sample mean. So sample mean, so variance of YOR of sample mean. Now for the sample mean, what it is, it will be n minus n upon n times n and s square, because this one is just y bar, so for this it will be n minus n upon s square. Now this s square is what? It is n upon n minus 1 times pq. So, sorry. So this one will be cancelled out and it will be n minus n upon n minus 1 times n pq. The similar way we can find the variance of this p under WOR also. Uh, okay. So variance and standard error of P under SRSWR. So these are some formulas which I'm writing so that we can work on that. Like when we will do the example, we can see that. So variance of WRP is PQ upon N, and variance of WR estimate P is PQ upon n minus 1. Here's variance of WORP. Okay, so WORP I have written as n minus 1 upon n minus 1 PQ upon n, and for here I have written already. So this is already written in the above. Okay, so we don't need to write it again. The next is so these are basically the variance and the mean. So whatever we have done in the population mean, it is very similar. All we need to do is that we need to just replace that y bar wherever was y bar to the p, because it was the y bar equal to p here, small p, small y bar is equal to small p, and wherever there was the variance, so s square is replaced by pq. So it is basically p, the probability of happening, and for not happening. Okay, so these are just similar. All we need to do is that just replace that s square by pq. Okay. Now the next thing is that estimation of population total or total count. So estimation of population total is basically what? So if let's, what we are saying that p is the proportion. So p is the proportion. So basically what we do is that it is like 40% of like 40% is agreeing, 60% is agreeing. So how do we know that? So let's say if n is 100, okay, and p is zero point 0.4. So this a cap will be what? It will be 40. So that one will be the total one. Okay, because till now what we were saying that uh, that 40%, so rather than 40% we can see that 40 is agreeing, so 40 is the population total because that is the population. From here, uh, or in other words what we can say is that from the just proportion we know that it is, okay, let me rephrase it. If it is, let's say b is point 0.6 and q is obviously point 0.4, right? But if n is, let's say, 10, then we know it is 6 and 4. So the sample whether it is good or not, so if n is like large enough, then it will make more difference to that. Like right now it is 6 and 4, so it is not more valuable. So whether that survey is more valuable or not, so population total is also one of the parameters, so we can see based on that. Okay, so here if we will say that variance of a cap, so what will be the variance of a cap? uh, a cap is basically np. Okay, so it will be variance of what? np, right? Now this uh, n n is not varying because n is the population size, but p, this p is mean of sample. So sample mean will change because we will take multiple samples, or we will take sorry, we will take sample again and again, so this n is constant. So as I have said that variance of ax is a square variance of x if a is constant, so it will be variance of p. And then we for estimate part, it will be n square and variance of p and its estimate. Okay, these are the things we have seen similarly in the time of population mean also. The next thing, the next thing we saw here is confidence interval. So as I have said, in the time of, like here it is population mean, and here, so okay, now again, what the need of confidence interval is same like we have done in the time of population mean. For the proportion also it is same, like in the time of that we have seen that, okay, so on an average, so like for time for something on an average, let's say it is 30 minutes, so it is not exactly 30 minutes, it is 29 to 30. The temperature we have discussed that for a healthy body, if the temperature is 37 degrees celsius, it is not exactly 37, it can be like let's say 36.5 to 37.5. So we can give some confidence interval that if it is inside this, then the chances are that this person is healthy. So this one was confidence interval for uh, mean. Now the confidence interval for proportion would be, so p, if it is like zero point 0.4, so it will not be like 40% is agreeing all the time because it is sample. So we need some kind of confidence interval, and based on that we will see that how the sample is real, has the variability. So if uh, the interval is very small, that means the variability is low, that inside this most of the population is coming. If the variability is high, that then the population will go outside that interval, so we need more values to cover that much percentage of population, so the interval becomes large. Okay, so we will see confidence interval estimation of p. Okay, so as I have said that whatever we do for p, it is just 1 minus for q. So we do not need to do that again. Okay, so now what we know is that p minus p divided by variance of p, that will follow n01 for n, n. Now, when we say large, so it is basically meaning in statistics we say sample or population, whatever it is large when its value is greater than 30. So there needs to be at least 30 elements for that. Now, uh, uh, it happens that when we say that if the population is large enough, then we can just standardize this and that will follow. So this will follow n01 standard uh, normal distribution. Okay, so again we are using the normal distribution right now because it is making our work easier, but we can use some other like for future in the work. Okay. Okay. Uh, so what we say is that we want to know that uh, we say that the probability that this one p minus capital P divided by variance of p is in between minus z alpha by 2 to z alpha by 2 is 1 minus alpha. uh, so that also we can see. So so if you will just take so basically the probability that some x less than or equal to uh, a. So here I'm saying it is, let's say, some CDF. So we say that some x is less than or equal to a. This one probability is alpha. So probability that x greater than or equal to a, that one will be 1 minus alpha. So from there we can see that. Okay. So here it is alpha. Now to find the confidence interval, all we need to do is that it will be p minus what we are doing is that we will just multiply this variance over this. So it will be z alpha by 2 under root of variance of p to p plus z alpha by 2 under root of variance of p. If you have any confusion, you can go through these slides uh, here. No, in this class. Yes, here we have seen that how we can find this interval. Okay, so this is p minus z alpha by 2 and p plus z alpha by 2. Now, uh, there is one thing there is called which is called that continuity correction. So what happens is that uh, when we are taking the continuous variable, let's say time, temperature, or etc., when we are doing that, so what happens is that this is continuous, so we can just say that it can be in between 36.5 to 37.5, let's say, right? But in the time of a discrete one, like let's say 40% is agreeing, so let's say 40% is let's say that my population is 100. Okay, so if 100 is the population, 40% is agreeing and 60%, let's say, not. So let's say in confidence interval it came as uh, let's say 37.5 to uh, 42.5. Now what we can do here is that, so here in the time of temperature is what okay, but right now if we will see, there is nothing like we do not have 37.5 people or 42.5 people. We need to have those in uh, the continuous form. So for that, because we are working with the discrete random variable, then we need to approximate it with continuous random variable, and that is called continuity correction. So continuity correction is done by n by 2, and then this confidence interval changed to p minus z alpha by 2 variance of p plus n by 2 and p plus z alpha by 2 variance of p minus n by 2. Now one more thing we need to notice here is that what we are doing is that we are increasing for the lower and we are decreasing for the upper. So what is happening, let's say when I said it was 37.5 and 42.5. Okay, so what we are doing is that we are, when we are increasing, that means we are taking 38 or 42, let's say, I'm just saying. So we are not pushing it to this side, we are pushing it to this side. So we are reducing our confidence interval. We are reducing our confidence interval, we are not increasing it. So when we are doing this correction, that means we are reducing it, not increasing for the real one. Okay. So the next is that we will do this sampling for the proportion and percentage in the R software. Okay. So now what we need for this, I mean we don't need it, we can just do some count or etc, but here we are using as dot numeric x. uh, okay, so let's say I'm taking some population, so I'm taking just pop by a population, and I'm taking, let's say, 1 to uh, let's say 25. Take it. Now, uh, what we can do is that uh, as I have said that we want to divide the population into two parts to understand the proportion one. So we can divide it into two parts by many methods. Like we can say that greater than, less than, we can say that whether it is divisible or not. So here we are taking based on even integer, let's say. So integer can be even or odd, it cannot be anything else. So uh, let's say I'm saying that uh, pop such that pop is uh, 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 okay. So I'm saying that it is, if it is divisible by 2, that means if it is even integer, then I'm considering it as yes, otherwise no. So if I will just write this. So you need to see that when I'm saying pop such that this happens, so it is giving me the numbers. But when I'm just doing that, it is divisible by 2 or not. So it is giving me false, true, false, true, false, true. So now we cannot work with this just uh, like true, false. It is tough to work. So what we do is that we say uh, is dot milk. Okay. So what we have done is that we have changed this pop by as dot numeric. So here now we can see that there are uh, 23 1 and 22, sorry, not 23, there are 13 and 12, I think this. So it will be 13 this and 12 this. So now we have 0 1 0 1 0 1. So this is our population. So now this population, which with this population, what we can do is that we can continue. Okay, so I'm just saving it in y. Now, with this y, we can take the samples. Okay. So, I'm writing y w o r when I'm taking samples from the size is equal to, let's say uh, some, let's say 9. Uh, then replace equal to false. So that is YOR. So it is 1 0 0 0 1 1 and then 0 0 0. So this is our uh, sample, right? Uh, and we can do it like multiple times to see others, like other samples also. So if we will take mean of YOR, it is 0.33333. Why? Because it is just uh, one. It is 3 divided by 8. Okay. So this one is 3 by 9. So we have in this sample we have 3 1 and other 6 0. So its mean is 0.333. So this one is approximately, it is saying that the mean of our real population. Anyways, so the next is that we have done the mean. The next thing we will do is that we will take this variance of y. So now variance of y o r This one is 0.25. So this one will be n minus 1 upon n times n. Let me just write it. So it will be square root of, let me open the file we had done in the last class. Okay, so here we have done the same things. So we have done n minus n divided by n times n variance of x1. So this is basically same, just the way of taking the population has changed. So it will be this n, capital N, and then uh, okay, so n I have not defined above. So n is I'll say that length of pop. So it is 25, and a small n is length of our sample. So it is YOR. So it is 9. Here you can see also. So this one uh, is square root of n minus 1 upon n. Oh, sorry.
One basis, yeah.
Yeah, say.
It's okay.
Yeah, so there was a bracket mistake. So if it is in divide, we need to write it here. Okay. So this one is basically the standard error we have found. The next thing is that in the similar way, like here, so the similar way we can make the sample of YR. So let me do for YR. So I'm not changing the size so that it will and will remain same. Just I'm changing this. Uh, so here the sample. So these are some I have done some 3 4 times. So uh, so here we can see that one is more in the first one, also one is more, second one also one is more, and third one also I think one is more. Anyways, so we can take like any some sample. We do not need to generate right now again and again, but you can try just for practice. So here the mean of YWR, this one is 0.55 and 6. So it is too long. So it is basically 1, 2, 3, 4, 5. So it is 5 by 9. uh, Variance, if we will calculate, so variance of YWR, so variance is 0.22, sorry, 0.277, approximately 0.2778. Okay. The next thing is that we will take the time when I'm not just changing this I'm just writing n minus 1 upon n into n, but we can just write, or we can see that how much difference it will create. So right now it is this. If I will remove the portion of this, sorry, and just divide by small n, then it is, so you can see that the difference is not too high, it is almost same, it is 0.1721, it is 0.1756. So that's why we say that, because n minus 1 and n will become smaller. So right now n is a 25, so that is why 24 by 25 is uh, 0.96, so almost 1. When it will increase, let's say 1000 by 1001, then it will become more close to 1. So that is why it is not needed after a time to write n minus 1 upon n, uh, for when we are doing with replacement. Okay. Okay, so this was very similar to whatever we have done here. uh, where is it? 0.17, and for, yes. So here we have seen that in the time of without replacement, we have seen that it is 0.13. In the time of with replacement, we are saying the variability is 0.17. Also, in the last class, I have given one proof. In the last class, yes. In the last class, okay, so I have given regarding this, what do you say? This confidence interval. So we will see the confidence interval also. Uh, but what I was trying to say is that confidence interval, you know that mean is not changing. Uh, Sorry, not changing means mean is like nearby, like it is not dependent on SRSWR or SRSWOR. It is only dependent on the samples. So we are not working with a mean, but here it's so QT norm. So whatever this value, this one is also same in the time of here. Let me do it like this. Okay, so in the time of with replacement or without replacement, the value of q norm is not changing, the value of qt is not changing, the only thing matters is that the variance part. And we have seen that in the time of this without replacement it is smaller, in the time of with replacement it is larger. And we have seen that the class ci interval, that this class interval, the SRSWOR is less than SRSWR. So here the interval will be larger, because the variability in the with replacement is larger without replacement. So here also we have taken random sample, but we can see that variability is less in without replacement, and in the with replacement the variability is large. So I have done a proof also, so you can go through in case you want. Okay. Okay. The So for the confidence interval, now what we need to do is that in the last class we have seen the confidence interval, there will be two types, that the population variance is known or not. So if it is known, we will use q norm. So here we have this what do we say, we have here mean, right? So we have mean, and then uh, mean, then minus q norm, minus q norm 0.975, and then multiply by, let's say I'm multiplying with the whole one. So this is the left one, and this is the right one. Sorry, it needs to be like this, and needs to be like this. Okay. So this one. Okay. So this one is left, this one is right. Uh, okay. So here, if we will see that uh, 0.89 uh, minus 0. Let's say 22, it is 0.67, whereas 0.59 minus 0.07, it is 0.52. So again we can see that when the variance, population variance is known, that means we are using q norm. Here also the confidence interval length, let's say, so length is 0.61 for with replacement, and 0.52 for without replacement. So what I was saying, I was trying to say in the last class and here also, that it is not just a coincidence that we are taking the sample in such a way that it is happening. It is not a coincidence. It is something, a fact, that it will be greater than or equal to. I mean, if you have taken like random samples in that way, if you have taken completely different way or something like that, maybe it can be wrong. I have no idea. Okay, so this is the confidence interval. Also, we have seen. Now, the similar way, in place of just Q norm, we can replace the Q norm with QT. This sorry, with 0.975, and n minus 1 is degree of freedom. Okay. So we have seen these examples. The next thing is that stratified sampling. Okay, so stratified sampling
Excuse
is
me,
the,
ma'am. One,
yes,
uh,
yeah.
just one sample if we are taking, suppose, and this quality sample is of a quality nature, that is
Hmm.
good and bad,
Hmm.
and we are converting them into the that quantity aspect.
Hmm.
So can we have one example for that particular type?
Uh, okay. Uh, so good or bad. So like you are asking for a real life example or something like that?
Not real life. Suppose let us have a population is there of some 100,
Hmm.
and we are taking out a sample of 10, good
Hmm.
and bad. But
Hmm.
it is not that more than 5 or 7. Alternatively, they can be, or even at random, they can be good and bad. Suppose first is good, the second, third, fourth are bad,
Hmm.
and then fifth
Hmm.
is. So
Hmm.
in that way,
Hmm.
we are converting it with the as numeric
Hmm.
command.
Hmm.
So can we have one example?
Yeah, what you can do is that you can just give it like, if it is
Here,
good.
in that case, population will be giving 1 to 100, or
Huh,
see, population is 1 to 100, so, or 100 population,
huh,
and good and bad survey has been conducted.
hmm,
Let's see, and a population of 10 people have been at random taken,
hmm. So
and out of that, yes, yes.
So, like whatever I'm doing, it is almost the same as far as I've understood. So, if it is, let's say you have 1 to 100 population in this,
Yes.
okay. The next one where I was saying that divided by two, because I'm taking this condition, in place of this condition, you need to give that array on your own.
Okay.
So right now writing that array will be a part, like it will be time taking. But when you have real data, so in the real data you do not need to give it. So when I'm writing this, so it is what it is creating basically a kind of good and bad, or
Yeah.
false and true, whatever it is. So right now it is creating like false true false true, but if I will
False
this
true.
do like this by 3, so it is creating false true, and then sorry, by 3 if I will do, it is creating false false true false false true false false. So it is creating like by 2. And if I will give any condition uh in that kind of, so it will give in that way. So but right now, like writing this for 100, that is a tough task, right?
Nee, I'm not talking about writing for 100.
Huh.
Just the conversion aspect I wanted to understand how we are
So
converting with the as numeric command.
as
The
numeric, okay.
qualitative.
So basically as numeric, what it does, so if I have this population by 3, so if I will write as numeric 3, so what is happening, it gives false to 0 false to 0 and true to 1. So if you will have good or bad, so we can give it that to bad give it 0, and to good give it
Good
1.
one.
So it is converting in this way. So for false it is taking 0, and for true it is taking 1. So it is basically converting the same population in that form of numeric, so that we can work on that later, because with the false and true we cannot find the mean or variance or anything.
Okay.
So
All right.
that is the only reason of s dot numeric. Okay. The next is stratified random sampling. So stratified random sampling. Now, till now, what we were doing is that we have basically taken into two parts, like a condition or a situation, anything, whether it is agreeing, disagreeing, or anything can be this. It is not just agreeing or disagreeing. Basically, that whatever is the population, it can be divided into two parts. So, what we have done is that. Yes. What we have done is that we have taken two classes. So from the population, I am taking a sample n, and then I am taking these two classes in a star. So I'm taking the sample only from the population, but in the stratified, it does not work like that. It works like that I'm dividing the population into, let's say, two parts. So I will take the samples from these two parts, not from the population. So in the stratified sampling, what happens is that, let's say I have a population n, and there are n. So it is, let's say, n1 size, n2, n3, dot 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 n k, let's say. So summation of nj for I1 to k, that will be n. Okay, in that form. Let me write it here so that we can do the sample one also. So if this, then we need to have summation, let's say nj j equal to 1 to k. This is n. So it is n1, n2 up to nk. This population is n. So we are taking the sample so that it will come from the each one. Uh, Now, why exactly is that? Okay. So samples, let me just write it. So samples will be taken from this. So from here, let's say I have n1, n2, n3, and up to a small nk. So these are the samples. Okay. Uh, okay. Now, okay. So now, stratified random sampling. Why do we need that? Because uh, the thing is, if I'm taking a sample, sorry, a survey on a whole population, let's say of India, okay, and I'm taking the samples randomly, what will happen? It may happen that uh, I have taken uh, I have not, like, there is a very less chance that I have taken from each and every state. Or let's say on a demand, that I have taken that on a demand, that, okay, uh, like, uh, exactly from each and every state, or let's say, or on a region, that northeast, or northwest, east, south. So in that four, dividing by four, so there is less chance, and there is high chance of variability. Let's say in the current time, the one of the reason is, we can see, is that on the newspaper is AQI. So AQI is basically air quality index. So now that air quality index, we have the weather details. Now if I'm saying that, if the AQI index is severe, which is in north, sometimes in Delhi, let's say in Kolkata, in maybe, I don't know, in Bangalore, or maybe in Mumbai, maybe like cities where the population is overcrowded, where the transportation is very high, the car, etc., and they are just, industries are so much, so they contributes to the pollution, right? So now in the time of this, if I will take, let's say, for whole India, and I have taken some sample, so this can create the diseases. Now disease is related to the heart, basically. So let's say I'm taking a survey on heart attack. So if I will take a survey, and uh because see, the budget also matters, so I cannot go to like 1 lakh or 10 lakh of the population for this. So if I have created that survey, and like I need to move to each and every, so what will happen, it may happen is that from the one part I have taken more samples, from the second one I have not taken the enough samples. So if I will take the whole India as one, so from the whole population, let's say here and here, so it may happen is that I have taken more from here, I have taken less from here. And I want to conclude, if I want to conclude, how I will conclude that, in the south region, the heart attacks are more, but this is not the reality, right? This may not be the reality, I mean, this can be, but I don't know. So it is not a good way basically. Also the like it the sample doing the sampling in this form can be typical also. So what we do is that we divide it into the reasons, so that it the variability among itself is low. So if I will take, let's say, from the population of Delhi, from the population of UP, then its variability will be low because the sample inside it will be homogeneous, right? Or we can work with something else also, like this one is AQI, heart attack, some other things also. Then we need to divide, like this one we need to divide by the reason. If we are dividing, uh, let's say the time when there was like the change of notes, that you need to replace your 500 rupees note, the previous one, with the new one, and you need to replace the 2000 one with the 2001, etc., etc. When that happened, so to which population it is problematic? The one, like who have this kind of income. So the one, like who is like uh, basically who have low income. So that person, most probably, like if you will take a street side food, so most probably whenever we to give the 100 rupees or 50 rupees, or let's say 200 rupees, so there is less chance that they have 500 rupees note. So for them it is not problematic. It is problematic to middle income, or more problematic to the people who have high income. So there can be a lot of things. So based on that, now if we will go to just people with a low income, and we will ask them, do you have any problem with that? They will say no. So most of the person will say don't know. So it doesn't mean that it is not problematic. It can be problematic for some other uh, population. But if we will take randomly, and we are saying that we have taken 70% out of them, so we are saying that 70% of the people does not have any problem, then it is not, it is a false statement. So that is why we need stratified sampling, and based on the problem required, we divide our population into that. So we can divide our population into income based, into qualification based, uh, or whatever is required. So in the time of marketing also, so if there is a person uh, with low income or middle income, that person does not get get very affected with some of the things, like, and it may happen that high if people income will get affected with this. uh, so these can be some things regarding this, basically stratified sampling. So all we need to do is that we need to firstly question our survey before dividing the population. We cannot just divide our population with any way. We need to firstly go through what can be the uh, division, and division in such a way that inside one, uh, inside that's n1, n2, n3, nk, inside it is homogeneous. So if we are taking based on income, so it needs to be low income, middle income, high income, based on that. So or l- let's say health, if you will take health, so we can divide in terms of cities also, or if we are doing the survey in one city, let's say I'm just taking in one city. So in one city, the it is same for all. So AQI is same for all. It can be a little bit different, like let's say it is ranging from 250 to 260 or 270 for one city, like based on the places. If you have plants nearby your home, it can change a little bit, but not very much. Then we can divide age wise, right? So we can say that with if a person is in between 0 to 18, so uh, if it is a children, then how the possibility of getting affected by a disease because of the AQI, then it is one group, then the middle group, and then the people most will be most affected, who are like older. Okay, so that time we can divide our population in that form. So what happens is that homogeneity inside the population, heterogeneity outside it. So these all are heterogeneous. If these both are not heterogeneous, then there is no part of dividing this into two parts, right? Because if I'm taking here, let's say I'm saying from the age, so if I'm taking here from the 0 to 18, and here let's say I'm taking 19 to 59, let's say, right? So if it is not heterogeneous, if it is not different, then this population may come here, this one may come here, and then it will create the problem because it is not different. So it needs to be homogeneous inside of it and heterogeneous outside of it. Okay, so this is basically the stratified sampling that we need to require for the certain parts and etc. What more important is that we can give uh, uh, like regarding one like we in the result also we can give regarding the different population. Like if I will do the survey of India and for the whole India, then I may be incorrect, but if I will do the sampling from one city to city, then there is a high chance that I will be correct because the sample is taken from that part only. Okay. uh, Now there can be a lot of advantages of stratified sampling. So if we are going to do the survey, what we can do is that, like if we can just uh, take, let's say, a group. So let's say a group of 20 people, and then we can go to like different reasons for that. Or in that time of division also we have already like sure that what is our mini population, so we can work with that also. So there can be a lot of advantages of this stratified sample. Okay. Okay, so the next one is that we will see that how we can find the mean etc of this stratified random samples. Okay, so uh, now the these one are called as stratum, sorry. uh, the each one is called stratum and the whole one is called strata. uh, so we just write it. So n is the population size as always, k is the number of strata. So n is the population size, uh, k is the number of strata, uh, and I is number of sampling unit in ith strata. And so n is basically what, summation j equal to 1 to k n j. So I have written this here also, but right now we will do the further calculation. So I'm just writing it. Ni is number of sampling units to be drawn from ith stratum, and n is equal to summation j equal to 1 to k, and j is total sample size. So this one is total sample size. Now, uh, so uh, y basically is characteristics under study. So whatever we want to work on that. So I'm just writing it characteristic, and yij. So yij will be value of jth unit in ith stratum. So that you need to remember. So if the first one I is ith stratum and j is that value. So value of jth unit in ith stratum, and then yi bar is basically the summation. So 1 upon ni, and then summation yi j, j equal to 1 to ni, because the total number is that ni. So this is the sample mean of jth stratum, and the capital yi is 1 upon n summation, let's say ni also, ni equal to 1 to k yi dash. So this is wi yi dash. Wi is ni upon n. Now, this is one of the thing which was not uh, earlier happening. So what we were doing is that we were just summing the yi only, but here what we are doing is that we are saying that ni yi bar 1 upon n. Now why is that? Because it is not important that all have the same population, right? Same population size. What may happen is that, let's say when I was talking about the cities, so cities, for the cities the population is different. For the north side, I think the population is very high. If you will move to the northwest region, the population is less, like Himachal, Uttarakhand, etc., the population is less. If you go to the northeast region, there also the population is less, but the nearby places, West Bengal, etc., the population is high. So the this part is also different. So if this part is different, the sample will also be different. It is not that the population size is, let's say, 1 lakh, 10 lakh, and 3 lakh and 4 lakh, and you are taking the sample size 100. It will not be it will not work like that. We need to take the weighted one, that how much is the weighted of one particular strata. Okay, so this one is the population mean. So this is the weighted mean. So here we will take the weighted mean. So next is that the population mean. We have seen this one is the population mean. We will see the unbiased estimator of population mean. So here we will see that, like the previous one, the sample mean, if we will do directly, that will not be unbiased. the other something other will be the unbiased estimator. Okay. So unbiased estimator of population mean, so if I will do estimation of yi bar, uh, so uh, if I will take this estimation of y bar of st. What is st? So s is s est stratum, and j is a unit of j value. So if I will do this, it will be 1 upon n summation n I no, yi bar. So it will be 1 upon n summation of ni, and this will be yi bar, right? So this will be capital Y bar, which is unbiased estimator. Uh, but if I will take uh, the Y bar like we used to do, uh, so if I take the Y bar from here, like right now, I have taken this Yij with the help of value of jth unit in ith stratum. But if I will take y bar like this here, so it is basically summation nk sorry, nj nj equal to 1 to k. This is n, right? So if I will take this, then it will be n I y I bar, right? I equal to 1 to up to k. So the similar one means uh, the weighted population mean. So here we have taken weighted population mean. So here I am taking weighted sample mean. So if I am taking uh, expectation of this capital Y bar, it will be 1 upon n summation. This n I will come outside k expectation of yi bar. Now this expectation of yi bar is capital yi bar, because small yi are basically one sample, sorry, so mean for one and second and third and fourth. So this will be ni, and this one will be capital yi bar, I equal to 1 to k. But this is not equal to 1 upon n summation uh, ni yi bar, I equal to 1 to up to k, which is not equal to y bar. So what we have understood is that weighted sample mean is not unbiased estimator of population mean. Let's say y bar, I'm just writing. So weighted mean is not unbiased estimator of y bar. The for the sample one, we need to take it directly. So we need to take expectation of yi bar here, and then 1 upon n summation nij will continue with this. So we need to take y bar st. So y bar st, so understand in this way. So uh, let's say y1 1, y1 2, y1 3, and y2 1, y2 2, y2 3, and y2 4. Let's say y3 1 and y3 2. So yst expectation of yxt st, so yst basically includes everything. So if we will take everything directly, then that expectation is, though that expectation is uh the unbiased. But if I will take the mean from here, mean from here, and mean from here, let's say y1, y2, and y3, and if I will take the weighted mean n1, y1, n2, y2, plus n3, y3, uh, divided by a small n, then this is biased. This one is biased. If I'm taking y1, so average is basically what? Y11 plus y12 plus y13 plus y21 plus y22 plus y23 plus y24 plus y31, etc. If I'm taking in that way, n divided by total n, this one will be unbiased. If I'm taking the weighted one, then this one is biased estimator. So this one is in the simple language. This one is the proof to understand, but sorry, to just calculation to understand is statistically. But here, if you want to understand in the simple language, then this one is the thing, that if you will take the weighted sample mean, then this one is biased. And if we are doing uh, the estimation of y bar st, then it is unbiased. Okay. Uh, so now the variance of stratum mean. So the variance of stratum. So variance of stratum means is that variance of y bar st. Uh, so this one is summation by wi square variance of yi uh, plus summation j equal to 1 to ni when j uh, when I not equal to j, from 1 to k, wi wj covariance of uh, yi bar and then yj bar. Okay. Okay, now why is that? So uh okay, if you will try to understand from here, so uh the expectation of y bar st is basically what? This one is wi, uh let me just write it. So this one is yi bar, capital yi bar. So if we will take the variance uh, of this, so variance of yst will be what? It will be just this wi is square, because the weighted is what? Capital Ni divided by n. This one is constant, because we know what is the total population and what is this population for ni. For one stratum, but we know what is the population, so this one is constant. So the variance will be summation uh, wi square variance of yi. Now this is this happens when uh, the uh, samples are dependent. What will happen? if you are taking the n in terms of that it is independent, right? So when it is independent, so covariance will be 0. Let's say I'm taking from 0 to 18 and 19 to, let's say, 35. Okay, age, and I'm working on any disease or something. So this is different. So covariance among them is 0. But if something like this happened and I'm not sure, so let's say I'm taking 0 to 20 and then here comes the 15 to 35. Then there is something which can be in these two. So that time we need covariance. So but right now when we are working with this stratified sampling, we are saying these n among themselves are heterogeneous. If they are not heterogeneous, we need to take care of the covariance also. But right now we are taking it is heterogeneous. So we will see that since samples have been drawn independently, so I'm just writing independently, so this covariance will be 0. So variance of yi bar, now it will be like in the SRSWOR, it is basically what, ni minus, sorry, not equal to ni minus ni, and then ni times ni si square. Okay, so this one was the variance. So this one when SRSWOR, in WR it is ni minus 1, or we can directly write uh, just we can just directly write by SI square upon ni for SRSWR. Now the variance of y bar st, this is yi square, and then ni minus ni times ni si is square. So I have just put here variance of yi here. So this one is the variance of y bar st. Now the important thing we need to take here, see here, is that uh, so this one is constant because capital Ni by small n, population is constant, this one is constant, this one is constant. Sample, let's say right now we are taking a constant. Let's say I'm taking the sample size of 20 only. We can see that when we change the sample size, what will happen. So basically, when we increase the sample size, variability decreases. But right now, let's say this Ni is also constant. What will happen? It is only dependent on Si square, right? Only dependent on Si square. So we can say that variance y bar st is only dependent on Si square. Now, what is Si? Si square is basically variance of this ith one. Okay. So Si is, so capital Si, this ith population, so ith strata. Let's say. So if I want to uh, decrease the overall variance, what I need to do is that I want to decrease the variance inside of a strata. So that is the reason we need to take the homogeneous population. See, it is completely dependent on SI square. So if I am taking homogeneous population, then inside inside one, let's say ni, the variability will be small. If I'm taking heterogeneous population, let's say rather than dividing into 10 parts, I have divided into 3 parts because I do not wanted to do too much of calculation or anything like that. What will happen inside one part? The so basically, let's say I'm dividing n into 10 parts. Here I'm dividing n into 3 parts. So here homogeneity is greater. Here homogeneity inside all 10 parts is more than homogeneity here. So here there will be more heterogeneous. More heterogeneous means the variability will be high. So if you want to see in real terms, so variability will be high means uh, there will be different opinions on that. So there will be high variability. So uh, variability will be high. So in total, it will create a problem for confidence interval or for anything or for making a conclusion. So if variability is too high, then concluding anything is not possible at all. So that is why, in terms of constructing strata, we need to take off homogeneous population inside one, and among itself, it needs to be heterogeneous. That's why we need to do the division there. Okay. Uh, so So the similar way we can do this. The This one is variance of y bar st. So if we want to find this unbiased estimator, so unbiased estimator we can find just by variance cap of yi. So unbiased estimation of y bar st. So variance we have seen already. So this variance, this yi bar, sorry, this one is yi square, variance cap of yi. So this one is yi square, and this one is ni upon ni, and ni times ni, and this one is variance cap. This one is basically we are taking the, so I'm writing by this small s square, and we can find the standard error, which will be equal to under root of variance bar of y bar st. Okay, so this one was for SRSWR. Now for SRSWR, for SRSWR, whatever uh, we were doing in the time of mean, etc., it will be just weighted. So this one, and ni minus 1 upon ni times capital Ni, uh, si square, and if it will be sigma I square upon uh, Ni, because if you will see, for si square it is 1 upon n minus 1, for sigma square it is 1 upon n. So basically ni minus 1 uh, upon ni Si is square is equal to sigma I square, because in the terms of sigma I square we takes in terms of 1 upon ni summation this, and in terms of si square we take ni minus 1 ni uh, into summation the other part. So you can directly write in place of ni by minus 1 si square is equal to sigma I square. Okay. uh, the next is the estimation of uh, y bar st. So this one is yi is square, si is square upon, and similarly we can give the standard error. Now the confidence interval, uh, so the confidence interval is basically again the same whatever we have done till now, that it is y bar st plus minus uh, that z alpha by 2 under root variance of y bar st. So you can see that the pattern is almost same in each and every case. All we need to understand is that what is the mean, what is the variance, and this part is also similar. Okay. So this one is up to today's class. So now we will see some questions. Okay. So the question is the simple. So a survey is conducted on 200 respondent regarding the taste of soft drink, coded good or bad. If 94 respondent report bad, what is the sample proportion of bad responses? So it is very simple. So it will be just uh, 94 by 200. So it is 0.47. You need to remember that whether it is given the bad responses or not. So if what if it is written what is the sample proportion of good responses, so make sure that you read the question correctly. Okay. So using the data from the question 1, what is the estimated variance of sample proportion for bad responses ignoring the finite population correction? So if we will ignore that, what it is, the estimated variance of sample proportion. So, in the last class, we have seen that uh, if this is our sample proportion, then it is this one is PQ uh, is the S square. Okay, so again,
Population correction, ma'am, until unless it is asked, we will not be doing it.
yeah, because almost it is same, I think. Like if your n is basically if it is increasing, even in the terms of we have seen that when it is 24 by 25, then also it is very close to 1, right? So
Okay.
so if it is not required, then we do not need to do. Okay. So, the population variance is basically the estimated variance is basically PQ upon N. So, so the this one is Q. So P is basically 1 minus this. So it will be 1 minus this multiplied by this and divided by 200. So it is 0.0012 455. So it is 455 is basically one 0.00125. So it is this. Okay. So in the last question, it is saying that what is the corresponding error. So error is basically under root of variance. So variance, we have this. So if I will just take the square root of this value, it will give me the standard error. So the square root of this will give me 0.035. So it will be 0.035. So right now, whatever question I'm doing, I'm taking the help of R. So if in your exam, the if the calculator, I don't know it is given or not. If not, then they will not give any question where it will be tough to calculate. Right now, I'm doing because I'm just using this. Okay. Uh, Now this is a sample, total sample question, right? Because what it is saying that the total population contains 1,000 individuals. If the sample proportion of bad responses is 0.47, then what is the estimated total number of individual who would respond bad? So if you have this, so what we have seen is that uh, population total before this here. So population total is basically n is this and p is the proportion. So multiply, if you will multiply, it will give you the population total. So here 1,000 individuals are there and the responses is 0.47. So if you will multiply, it is 470. So the 470 have responded back. Now, uh, uh, which of the following is the correct formula for estimated variance of sample proportion? So we have just done. It is basically PQ upon N. So PQ. So when estimating, it is P bar Q bar. So Q bar we do not estimate, as I have said. We When we estimate P bar, we write Q bar as 1 minus P bar because that will be similar. So P bar times 1 minus P bar divided by N will be the estimated variance. The next question is that in a study using simple random sampling with the replacement, 150 students are surveyed and 120 are male. What is the sample proportion of male student? So now we know that whether it is SRSWR, so whether it is with replacement or whether it is without replacement, it doesn't matter. We take the sample proportion in the same way, which is P by N. So it will be 120 by 150. So if you will divide, it will be 3, 4, 5 times 2, it will be zero point 0.8. Right. Now, in the for sample in question 6, that means in last question, what is the estimated variance of sample proportion of male student? So again, this one is the similar question. So this one will be uh, zero point 0.8 times.
Just excuse me. While solving the questions or assignment questions, do we need to compulsorily use the R or without the using R?
No, it is not important. Like
Okay.
you need, if you have understood, see, like in this question R is not required, but I do not want to use the calculator some other way. Like I can use the calculator
Right.
directly. It is not important to use R. All
What
you need to.
I was actually
Hmm.
okay. What the meaning? I was taking that I need to write the codes for R and then execute those commands. And so I was trying that way. I
I
actually I got it very good. That was I was getting the help from other sources also,
hmm.
and I read the R. So I'm doing, but I just want to know whether I need to solve these through R or not.
You don't need to, but I will suggest that you will. The reason only is that, like, when you work with the softwares, what happens is that, because right now we are working on very small population or anything. Like,
Yes.
Like, yeah, right now you have asked why we are using s dot numeric. Now if you have really big sample and you are working on that, you're not gonna like count on your hand that
Yes,
how
yes,
many false,
exactly.
how many truths are there. So you can take help of software. So whatever you will do, if you are working on the field of statistics, you need to have command on any software. It is
Yes,
not important on R or Python or MATLAB or anything. If you are comfortable in Python and you want to understand the basic of statistics, understand statistics from here and take write the command in Python. It is not
okay.
important like do in R.
Okay. Basically, actually, I'm working in audit department, so we
Okay.
need to go for using the tools.
Hmm.
We have idea software
Hmm.
uh, in our department. So we used to go for sampling of
Hmm.
data. We used to
Hmm.
go in field, and we have a lengthy data. So my department has advised that you should go through this. So I was trying to work through this R also.
Yeah. So if you are like comfortable in some other language, I will suggest you can work on that. It is not a necessity. I mean, do if you want to give exam, then okay,
Yes,
just for
I have
this.
to appear for the examination,
Yeah.
and I want to learn this language as well.
Because for statistics this one is good, but like for companies I have seen that they take care
Yes,
mostly in Python. So
yes,
if that is the case, then do it in Python, because
Python.
like commanding in one language is more important than understanding each and
I'm
every language and not have command at all.
okay. Okay.
Because for me I think like because I'm also learning, I'm also a student, so for me I think more important is that understanding the what is the basics. Coding you can do by any way.
Yes, yes, yes. Right.
So uh this and the total population we have here is that 150. So it is 0.0010 uh 106667, so it is 0.00107. So this one is estimated variance. Okay, so for the error in the last question is basically, see, if I will take a square root, so 0.0327 will be the error. Okay. Uh, the next question is that in stratified sampling, overall estimator for the population mean is computed as a weighted sum of stratum means. Which of the following correctly represent this estimator? So, y strata we have just seen uh, here. So y stratum is basically by summation yi capital yi ni capital Ni by Ni. Uh, so it will be capital Ni by Ni. The next is that in the stratified sampling design, where each stratum uses SRSWOR, which of the following expression correctly represent the variance of stratified uh, uh, mean estimator? So, uh, this one we have seen it is Wi is square Ni minus Ni upon Ni times Ni Si is square. So this Wi is square is what? This is Ni divided by Ni square, right? And if I will take this, if I will divide by capital Ni, what I can do is that take a small ni outside, divide by capital Ni. So this one will become 1 minus ni upon capital Ni, and this omega or wi square is ni square upon n square. So the first one will be the correct answer, which is summation ni square into si square upon ni in bracket 1 minus ni upon ni. So this one is correct answer. The next question is that which statement about the biasness of stratified estimator y bar str is true? Uh, so y bar str is biased if individual stratum mean is biased. Y bar str is unbiased provided uh, each stratum is unbiased. Uh, Y bar STR is always biased regardless of sampling method, and biasness of Y bar STR could not be determined without knowing the stratum variance. So last one is incorrect. We know that we do not need stratum variance to be known for finding the biasness of Y bar STR. The C is that it is always biased, so this is also not true. Now the A part is that Y bar STR is biased if any individual stratum mean is biased. So individual stratum mean is like we are taking the population Ni, and the small one is Ni. So we know if I am taking the mean of this, then this one is always unbiased estimator. So the B one will be correct, provided that each one is the unbiased.
Yes.
Okay. In a survey where the responses are recorded as good or bad, which method is most appropriate for estimating the proportion of good responses? So, calculating the sample mean, calculating the sample variance, counting the difference between good or bad, or dividing the total good responses by the square of sample size. So, this is not true. This is also not true, and
C is also.
s-
Yeah.
this is also not true.
Sample
This one
balance
is.
is also bad.
See, for the good responses, uh, if it is good or bad, so we do 1 and 0. If we will take the mean, this p, then this will give the proportion of good responses. This is small p. A uh, small p give the proportion for good responses, and a small q will give the proportion of bad responses. So for good responses, all we need to do is that we need to find the sample mean. If it is for bad responses, we need to find 1 minus sample mean. The next question is that in a sample of 100, this one is uh, for the positive response, then what is the standard error? So this one is again very similar. All we need to do is that 0.65 into 0.45 and divided by 100. The last question is
PQYN, na?
yes. In the last question, it is that given that in stratified sampling with proportion allocation, that means the sample size in strata proportional to their population size, what is the primary advantage of this allocation? It minimizes the overall sample size requirement, it ensures the overall estimator is unbiased, it minimizes the variance, and it simplifies the computation of standard error. So, what it does?
Yes.
I mean, it does all of the things, but what is the most, what is the reason why we do that. The primary advantage of how to select strata is minimizing the variance of stratified estimator, because overall sample size, it is not always
Not
like, yes,
reducing,
yes,
minimizing.
and overall estimator unbiased, we already know how to find unbiased estimator of a strata. We know the computation of standard error, there is nothing to simplify like this, so we need to
Hmm.
have the variance less. And here we have seen, uh, here, so we have seen that if the population is, we are dividing in more stratum and it is homogeneous inside it, then the variance reduces, so variability reduces. That is why we use this stratum. Okay,
Minimizes the variance.
yes. So these are all the questions for today's class. If you have any doubts, you can ask.
Was thank you, ma'am.
Okay. Okay, then I'll end the class. Okay, thank you.